Okay, we're carrying on with example 6.8. There's a lot in here, so I don't want to make each video too long, so that's why I've broken it up. So we finished part A. We finished part A. Now we're going to look at part B, where these two cars, the same inertia, are traveling at each other at the same velocities. Okay? So you can use this guy, K system in the Earth reference frame minus the kinetic energy of the center of mass is equal to the convertible kinetic energy. Or you could just use the formula. I know you guys are going to just gravitate towards the formula, but the reason I want to do it this way in the previous video is because it gives you more of an intuitive understanding what's going on. Whereas this, you just memorize a formula, you get an answer, and you move on with life. Okay? Maybe you're happy with that. So, again, if you want to calculate the convertible kinetic energy, you need the reduced inertia. You need the reduced inertia, and you need the relative velocity. Reduced inertia, relative velocity. The reduced inertia is just multiply the two inertias together and divide by their sum, which equals 500 kilograms. That's what we see there. And then you also need this relative velocity. And in the second scenario, what is the relative velocity? V12, it is minus 6.7 minus 6.7. And so, or depending on what direction you take, but the point is the magnitude of that is double 6.7. So we've got this 13.4 meters per second. And so if you plug all those guys in, you're going to get this 45 kilojoules. The convertible kinetic energy is 45 kilojoules. Okay, great. Now, what fraction of this 45 kilojoules, what fraction of the total system kinetic energy in the Earth reference frame is this convertible kinetic energy? How are you going to do that? Well, you have to calculate what is that. So it's half m1 v1 squared plus half m2 v2 squared, which is a half times 1000 times 6.7 squared, and they're both going at 6.7 minus, but they're both squared, so you just multiply this by 2 and you're going to get 45 kilojoules. So the convertible kinetic energy was 45, the total system kinetic energy was 45, so the answer is 100% of the system kinetic energy can be converted. Now, what does that mean? In the first one, remember that your KE system is equal to K center of mass plus non-convertible plus K convertible. Remember? This is made up of two components, your non-convertible kinetic energy and your convertible kinetic energy. In the first one, A, you had this as 0.5. So 0.5 of this was converted to kinetic energy. And in B, all of this was converted into kinetic. What am I saying? All of it was convertible into internal energy. Okay? So now, let's have a look at this. Why was some of this in part A convertible, 50%, but in part B, all of it was convertible? Well, it has to do with this guy. What was this guy in part A? What was the velocity of the center of mass in part A? It was 3.35. So because the center of mass had a velocity, the kinetic energy of the center of mass, there had to be a kinetic energy of the center of mass because the center of mass had a velocity other than 0. But what is the velocity of the center of mass in this guy? Do you want to try to calculate it? You will find that the velocity of the center of mass here is 0 because they're both coming at each other at the same velocity. So the velocity of the center of mass in this case is 0. So that means this will be 0. So all of the kinetic energy in the system can be attributed to convertible kinetic energy. Okay. See you next time.